Assalamualaikum and a very good day to you all. In this video, I would like to share with you about Lagrange multiplier. Okay, this is the last part of partial differentiation. So this is also a tool that we can use to maximize or minimize stuff. Okay, so usually we've learned before in SOPDIT, we can maximize the profit and we can minimize cost, for example. But in the case of Lagrange multiplier, in the question we might spot two things. The first one is what we call objective function, fxy, denoted by fxy. And another function is what we call constraint function, gxy. Okay, so how to know which one is which? Okay, it's simple. Okay, the question must give an objective functions and another equation that restrict the objective function. So if we have two functions f and another function g, which the f, okay, which fxy is restricted by, not restricted, the word I'm using subject to. Okay, at the fxy given subject to a certain constraint. Okay, so for example, maybe our fx is our cost, and then this is our quantity of material. Okay, quantity of material, or maybe production level. Okay, so we might our cost might bounded by this constraint. Okay, so in this in your syllabus now, you are dealing with one constraint only. But if you are going further way up in higher tertiary education in university, you might find Lagrange multiplier with a multiple constraint functions. Yeah, so let's look two examples how to spot them. Okay, so let's consider this one. Find the minimum point of the function fxy, 18x squared plus 9y squared, subject to the constraint x plus y equals 54. Now, this one it is very straightforward. Okay, how to spot, but still we can use several tips on how to spot a function to one function to be objective function, and another one is constraint function. Okay, objective function is the one that we want. Objective is you confuse blue lah. Objective is the one that we want to maximize or minimize. Okay, so as you can see here from the sentence, minimum point of the function fx. Clearly, this is our objective. Okay, so this 18x squared plus 9y squared is our objective function. Because why? We want to minimize this function fx. Okay, so I rub this off. Okay, because we want to minimize this function. Now, the next one is how to find constraint function. As we discussed earlier, constraint function is the one that bound the objective function, bound or restrict the objective function. So it cannot way past certain criteria, certain parameter or something like that. Okay, so over here, the constraint function is x plus y equals 54. But we have to adjust this one a little bit. Okay, we have to make sure everything on one side and then equals 0. So we take this whole lot and put it here. Okay, 54 equals 0. I know you might be alerted by these two equal sign on the same line, but this is the special case for Lagrange multiplier, for the constraint function for Lagrange multiplier. Don't worry much about it. Okay, but this is the way of the way of finding it lah. Okay, so from this example, our objective function is fx 18x squared plus 9y squared subject to the constraint function gxy x plus y minus 54. Okay, so obviously we want to minimize. Okay, let's have a look at the second one. Okay, you see very quite intimidating, because the sentence is very lengthy, quite lengthy, but that's fine. Okay, the profit function of a firm is given by pxy 1880x minus 2x squared minus xy minus 3y squared plus 100y, where x and y are number of units sold for the commodity M and commodity N respectively. The maximum output capacity for both commodities is 12 unit. Now, there are no two equations in this one. So, we need to find the objective first. It's easier for us to find the objective first rather than the constraint. Okay, because you might be confused. So, as I said, objective is the one that we want to maximize or minimize. So, maybe we can look over here, the maximum. You see the maximum? Maximum what? Maximum output. Output commodity. Sorry. Output commodity pula. Wait lah. Maximum capacity. Oh, no. Sorry. Okay, sorry. Okay, this one. We look at the profit function. Okay. Now, when we say profit function, for sure we want to maximize, right? So, profit function automatically is the objective function. Why I do red color? Blue color supposedly. Okay. So, we copy paste here lah. I know this one they use P, but we can just change it into F if you want, because later we'll get more confused. So, 80x minus 2x squared minus xy minus 3y squared plus 100y. So this is our objective function. So this is a profit. So clearly we want to maximize. So I rub this off. Okay, cancel this one. So we want to maximize objective function fxy blah blah blah. Okay, now the second one, we want to find the constraint. As I said, as we discussed earlier, okay, constraint function is the one that bounded the production. This is the profit function. So we need to know the x and y, right? But like a machine or something like cannot run forever. Okay, because cost the labor, electricity cost, okay, and then material uses more material like that. So we must have a certain constraint. Now, the constraint we can get from this sentence, the maximum output capacity for both commodities is 12 units. Both commodities means the sum. Okay, this one means the sum of both commodities. Satu pula. Why? Okay, and it says the maximum must be 12. Maximum must be 12. It cannot be more, it cannot be less. So, it must equals 12. So, this is the constraint function. As usual, before we want to put inside here, we must adjust it a little bit. So, x plus y minus 12 equals 0. Then, we copy, paste. X plus y minus 12 equals 0. Okay, so I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.